Uganda Science Teachers Association, Worcester, simplifying learning and applying knowledge through the SCC system. Our offices are located at Chengela, Chilombe. We also have Worcester tea, Worcester chocolate, and Worcester coffee to facilitate our program, preventing against cancer, diabetes, pressure, and other ailments. Find our products at Ham Shopping Ground, opposite Main Gate, and other supermarkets, all shops, or call us on 0700 52 88 99 to support teachers' programs.
I welcome you to our Science Advocacy from Worcester, Uganda Science Association will simplify learning and apply knowledge through the ACCC system. So, with you, Server Asule MHD, to take you through our quantitative analysis question 4. We ended looking at heating as part of any food of substance state. Now, something to add on that we did not talk about is if the residue is white on heating and it remains white on cooling, we are supposed to record the following. If the residue is white on heating and white on cooling, we are supposed to put there the following: calcium oxide, magnesium oxide, and aluminium oxide. So those ones there are the ones which are white on heating and they remain white on cooling. But now, if you see the residue is yellow on heating and white on cooling, it will be zinc. And if you see white hot and white cold, do not put here zinc oxide. Do not put here zinc oxide. You put those ones there to their respective ions: calcium ion, magnesium ion, and aluminium ion, as the marking guide clearly indicates it. Then let us continue to part B. Part B, they are telling us to two sparta handfuls of our substance. Okay? We add the nitric acid, so we get two sparta handfuls of our substance. We add dilute nitric acid. Let us add dilute nitric acid to it. So this time we don't have effervescence. We don't have effervescence. That means there's no gas coming up. And since they have told us to get a solution, that means everything here is supposed to dissolve. We are supposed to apply the possible means of dissolving it. So we set our substance and see that it dissolves. Whatever is inside here is supposed to dissolve there. That it has dissolved, it has formed a colorless solution. Now we go to part the part of it. They tell us we add the nitric acid. We add the nitric acid until the salt are just dissolved. Then we add sodium hydroxide solution to it. We filter, keep a filtrate and a residue. So there we get our substance which are dissolved. We add sodium hydroxide clockwise until in excess. And since they have told us that we are supposed to filter, that means the sodium hydroxide is going to be filtered. The sodium hydroxide is going to be filtered within the solution. We get our funnel. Let's use this funnel here. Get our funnel and organize our filter paper. And then get our water as usual. We organize our filter funnel. We get our solution containing sodium hydroxide and the sample, we filter it. We obtain a white residue down, a colorless solution down, and a white residue. A colorless solution is down here and a white residue up there. A colorless solution is the filtrate and the residue is white. We go ahead. After filtering, we keep both the residue and the filtrate. So this is our filtrate, colorless filtrate, still making soap, and the residue is white. Then we continue to part C. To the filtrate, we are told to add dinitric acid, and then make the solution just acidic. We divide it into 5 portions. Then we add sodium hydroxide. So we obtain our sample. The filtrate, we add the nitric acid, it. Until the solution is just acidic. It's just acidic. After that, we have been told to proportion it into 5 parts. Then we separate 1 cubic centimeter on it, 1 cubic centimeter of it, and then we do as you have been told. They are telling us we add sodium hydroxide clockwise and in excess. So we add sodium hydroxide clockwise until in excess. Like I told you, 1 drop is enough to make a change. So white precipitate soluble in excess. 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 What are you going to make? We shall say that we shall put our zap there, and then we go to next part To the next acidified solution, we add ammonia solution dropwise until excess. So we get our sample, get a clean test tube, remove 1 cubic centimeter of it. Go ahead to add ammonia solution. So we are adding ammonia solution on this one here, drop by drop. Remember, always add it drop by drop. One drop may be enough because there's change. For example, it has come. And the next drop may be causing another change. Good enough, this one here is behaving very well. So we are adding in excess. After that, we try to check this soluble or insoluble. It is soluble in the excess. You see, we get a white precipitate soluble in the excess. So this is very white precipitate soluble in the excess. What does it mean? This one here is not there, that one is also not there. So what is there is the zinc. So the zinc is there in that part 2 of part B of Roman number 2. Then we go to the next part 3. Part 3. To the third part of the acidic solution, add 5 drops of concentrated nitric acid, followed by 1 drop of starch. So we get our sample. And then we deduce 1 cubic centimeter. 1 cubic centimeter. And cubic centimeter. From there, we add concentrated nitric acid. Care must be taken when you are handling concentrated nitric acid. What has it done? It has turned to brown. So record that observation. The solution turns brown. This one turns brown. You see it has turned to brown. What does it mean? Remember, on heating, we saw the iodine gas being given off. That means inside here, the iodide has been converted to iodine solution. The iodine has been oxidized to iodine solution. This one here has been oxidized to, and this one which is brown, this one here is colorless. So the iodine which was present inside here has been oxidized by the concentrated nitric acid. Remember, in the preamble, I told you one of the uses of concentrated nitric acid is for oxidation. So this one here has been caused with the electron from iodine, the one which is appearing brown here. Then we are going to test using the starch solution. So you are adding 1 to 2 drops of starch solution. See what will happen on the starch. Let us add the starch. What are we getting? We get a blue-black solution. People of biology, this one know very well. Starch with this iodine forms a blue-black. So this is the confirmation that iodine is the one which has converted it, and the iodide ion is present. You follow that one here in the right. Then we got the next part. The next part, they are telling that the fourth portion, which is acidified, add 2 to 3 drops of silver nitrate. Followed by dilute ammonia solution. So we obtain our sample and get a clean test tube. Get 1 to the center of it. After getting 1 to the center of it, we are supposed to add the silver nitrate solution. Add their silver nitrate solution and see what is happening. What is happening is that we get a faint white precipitate. A faint white precipitate. Right? It's a white piece but faint. Then what happens when you add the ammonia solution? When you add ammonia solution to the faint white precipitate, the precipitate does not disappear, it remains there. It remains there, does not disappear. So you make the observation, while the precipitate is solved in excess, then you conclude iodide. Then we go to the fifth part of Party C. The fifth part of Party C. They're telling us to the fifth part of the acidified solution, we add 2 to 3 drops of lead to nitrate. 2 to 3 drops of lead to nitrate solution and see what will happen. So we get a clean test tube. We get a clean test tube and then we get our sample. Then we follow it with lead to nitrate solution. Add 1 to 2 drops. So we have seen a yellow precipitate. What does this one here mean? This one is fully confirming the presence of iodide ion. This one is fully confirming the presence of iodide ion. So now we are having little iodine from there. The little iodine from there is one which is a yellow precipitate. This one comes as a result of addition of little ion from little nitrate and the iodide ion is the one which forms the different, which is zero. This one here is the one which is confirming little nitrate. So if you try to follow whatever we have guided you with, you will eventually end up with success in this paper. Allow me to guide you in what you are supposed to use in your conventional tea, please. We have Usati. It's very good for those who are taking tea, please. Do not avoid it. Then we have Mr. Coffee. Please visit the supermarkets wherever they are and access them. Then we have the Mr. Apple very big product, but quantified with the elements of good life. And then we have the Usa aroma. Those who are taking milk, please visit the supermarkets and then get that product, enrich it in your daily consumption. Then we have the Usa masala, the flour masala, and the mixed masala for sauce. Please go ahead and use them in your daily food consumption. Then allow me, please, to convey my sincere thanks and greetings to number one, as you know, His Excellency, the President of the Republic of Uganda, for his very good advocate of science, and then number one, flying His Highness, the Kabaka of Uganda. Long live Your Excellency, long live Your Highness. I beg we shall meet in the conclusion of the paper. That's part D, as we shall be concluding our trial papers. Thank you.